will begin this panel by doing something fascinating. We will begin by zooming out, looking at our small home, this planet, our only planet, our Plan A medium-sized planet, a third one from its sun in a vast spiral galaxy with a thin biosphere holding the thing we call life. Mr. Fuglesang, Sweden's first and so far only astronaut, and now at the Royal Institute of Technology. Welcome.
Actually, I'm not the only astronaut from Sweden anymore. Marcus Swann flew in space a little bit over a year ago.
Okay, so thank you. Sorry about that.
I have a finer colleague. I'm so happy about that. Anyhow, that is our blue marble. This iconic photo was taken by the Apollo 8 crew on the Christmas Eve in 1968. And they had orbited the moon, and they saw this beautiful blue marble rising above the horizon of the moon. And it's been often said that this is maybe one of the most iconic photos taken ever, and has been maybe the originated the environmental movement. And actually the astronaut who took it, William Anders, he later said, we went to explore the moon and we discovered the Earth. And when you see the Earth like that, you really we better take care of it. Now, only 24 people have seen this with their own eyes. And that was in the late 60s and early 70s. No one had been towards the moon for 53 years. But we are going back. This was taken as a series of photos on an unmanned mission, Artemis 1, a couple of years ago, in preparation for the next manned mission. So hopefully the next year, in February 26, will be for humans again seeing this. Maybe no plan on the moon at that time. But the Earth is beautiful, and you get very special perspectives, even if you are in what we call low Earth orbit. So that's me there with the back to the camera, during my first spacewalk on my first space flight. And the photo was taken by our commander, and it's maybe not as iconic as the one from the Apollo 8, but it's actually become quite famous as well. That it ended up at the website for travel. And someone gave it the name, the Travel Picture of the Year 2006. So it's not my name for the photo. I kind of say I agree. And what you see below there is New Zealand, with the South Island to the left and North Island to the right. I was there taking part of building the International Space Station. This fabulous, enormous laboratory and little home for many astronauts over time. People have been living there continuously since almost 25 years now, doing research, learning how it is to live in space, and watching our fabulous Earth, the blue marble. When you have a bit of time over, you never get bored by floating to a window and looking down. And it takes only 90 minutes to orbit the Earth. And when you go on one orbit around the Earth, the Earth itself has spin a bit, and you see new things. And astronauts take photos. NASA puts all the photos of our beautiful planet on a website, which is open for everybody. There are literally many millions of photos there. Sometimes it's easy to recognize where you are. Like down left there, you see the Red Sea and the Nile on the left, and up in the middle is Sinai, and the very far up there is an area which is unfortunately extremely bad for humans right now. And what you do not see when you orbit the Earth is borders between the countries. And you get so sad to think, why are we fighting down there for these imaginary lines which doesn't really exist? That's another thought which kind of comes to your head. We were When I was on the space station last time, we were 13 people from 5 different countries, and we worked together to solve the problems there. And we need to do the same down here. By the way, it's harder to realize where you are if you don't know where the north is. Up right, I don't know if anyone has figured out where it is yet, but north is down left. That's actually the Strait of Gibraltar, with Africa up right and Spain down left. You can see the Gibraltar. Well, sometimes you just marvel over the beautiful colors and shapes, like this atoll outside Australia. You cannot see the Chinese wall with your bare eyes, that's a kind of myth, but you definitely can see effects of the human constructions, like this, which looks like a piece of art, right? Well, it's an artificial lake in African Cameroon. You can see one river coming down from the top right there, and then it's another river that's been dammed up and created a lake up in the river arms, and the sun is very low, giving this glint effect. Otherwise, it's really nighttime when you realize there's a civilization on this planet. And to me, it was almost the most fascinating, floating over inhabited areas, nighttime, in particular areas you knew well. It was like floating over a huge map. Big light blobs, big cities, and small light blobs, small cities. And cities are often outlined along the coast, so you get the coast lined out. Even if you cannot read down there, you probably recognize the southern Italy there, with the heel there, the toe, Sicily, and this big blob up there, that's Naples. You may see a black circle there if you have good eyes in the middle. That's Vesuvius, and Vesuvius is a national park, so you're not allowed to build there. You never have to wait a long time to get these beautiful pictures of sunrises and sunsets. You have 16 of each every day. But when you see this very thin colored line there, mainly blue, and you realize, well, that is our own living sphere. That's about 100 kilometers. That's why we say space stars. But it's only the 5%, the 5 kilometers closest to Earth here on top, where we have enough oxygen for us humans, or most animals actually, to live without a spaceship or a spacesuit. And we were very careful on our spaceship to take care of our environment, the atmosphere there. If things would have gone wrong, we wouldn't have had a lot of time to kind of solve our problems. Well, we have more time on Earth because it's bigger, but we still have to take care. Actually, the whole Earth is like the spaceship for all humanity in the immense universe. And compared to the universe, this really little dot, blue dot, the Earth. However, maybe most emotional, that's when you see your own home from space. That's where we are now also. I cannot brag, I took this photo myself, but it was taken from the International Space Station a few years after I was there by Scott Kelly. And he was lucky. Actually, you only had a few minutes every day to maybe have a chance to see Stockholm. So I did see Stockholm from space, but not this good, with no clouds. And in addition, an aurora in the background. Now, to see our environmental effects, you don't really do that from just one space mission. You need to accumulate data over time. And that's what's been done since the beginning of the space age. The first satellite was launched in 1957, Sputnik. And when you compare over time, that's when you see what's happening on our Earth. Here is one of the many bad examples. What you see left there from 1985, that's actually taken by astronauts on the space shuttle. That's the Aral Lake. The Aral Lake, which once was the fourth largest body of sea and land on the Earth. But in the 60s, they started to divert water from the rivers feeding the Aral Lake, Surdarya and Amur Darya, to kind of fertilize and grow things. and water stopped to feed the lake. And you can see how quickly it finally, almost everything went away between 2006 and 2009, a series of photos there. And today, the only thing which is remaining is basically the left part there, and a little bit on the top. So we learn a lot from studying from space, and we can see what bad things we can do. And when it comes to climate change, most of the knowledge and data which tells us what's going on here on Earth is from space. And here is a nice example, I think. It's data from an European environmental satellite, ENVISAT, which was operational in 2002, 2012. Took a lot of data, but what it's studying here was the amount of carbon dioxide in the atmosphere. And here is a time series over 3 years showing how much carbon dioxide the level is from month to month. And it's amazing because you can like seeing the Earth breathing. And when there's sun in the North Hemisphere, we grow a lot of things. The forests are growing, and you can absorb carbon dioxide. And then the carbon dioxide level on Earth goes down slightly then. But then comes the winter, and in the winter north, there's not so much vegetation in the southern hemisphere. So the vegetation totally is not absorbing so much CO2. And then the CO2 level increases. So it actually goes up and down a bit over the year, but for every year, each month, the corresponding months, it's more and more carbon dioxide. And this is at the root of our most problematic climate problem right now with the temperature increases. Right? But it's amazing to get a feeling our Earth is live, it's breathing in and out, like we are breathing in oxygen, breathing out carbon dioxide, whereas vegetation is doing the other thing. Well, I want to leave quickly planetary health, terrestrial health, and just to say a few words about extraterrestrial health. Actually, to be honest with you, it's not really healthy to go to space, but it's really fun, so it's worth it. But you have two bad effects there. One is radiation, which is not too bad when you're still just on low Earth orbit. The space station where I was is around 400 kilometers altitude. It's worse when you get to the moon and Mars. But then there's a weightlessness. And being weightless in a long time, it affects most of our human systems, and most of them negatively. We study that a lot on the International Space Station, so astronauts are really guinea pigs there, and many experiments like the one in the middle there is done. One of the things which are most obvious to you, when maybe not up there, but you come back, is that your muscles and your bones gets very quickly loses mass and strength. And therefore, astronauts, particularly if you live a little bit longer time, and on the space station, most astronauts stays there for half a year time. They have daily on their working schedule, twice, physical training. So there's a lot of physical training doing that. It's no problem as long as you are up there, because you don't need your bones and the muscles very much. But if you don't do the good training, you will be wrecked when you come back. And here you see photos here, various training equipments exist. The one left over the photo is kind of interesting, because that's strength training. We normally use weights for that here on Earth, right? Well, it's useless to use weights in weightlessness. And since that came into being, people come back with slightly less bone loss. Well, I've been thinking about back to the terrestrial health here, planetary health. And being space guy, of course, I think, well, is there anything we can do with space to help our terrestrial health? Maybe we cannot cure the illness, because that needs to really get down the carbon dioxide level in the atmosphere. But at least we can lessen the symptoms some way, to lower the fever. Some countermeasures to the increasing temperatures, which is kind of what will cause the most problematics for our societies and economies. And while being in space, let's think of putting a lot of sunshades in space between the Earth and the Sun to block off a little bit of the sun which comes to Earth. And if you can block off order 1%, you will decrease the temperature with order 1 to 2 centigrades. And that's probably, in my view at least, a less invasive thing to do with less bad side effects, risk for side, like other geoengineering solutions with atmosphere, like stratospheric atmosphere aerosol insertion. So I argue this can be done. It can be done because there's very cheap rockets coming up now, like the Starlink, SpaceX new system. It will cost order of $10 trillion, but this is actually still a fraction of what the cost would be to economy and society and things like that. If you don't do anything and the temperature will increase with maybe 2 degrees to even 3 degrees above pre-industrial times. So I argue that we should develop this system technologically such that it could be ready, like a climate insurance, in case we need it. Hopefully we should not need it. But it's stupid not to have alternatives, like an insurance. All right, I will end up with a little planetary simulation.
Har ju rymdfärger små
When you drink water,
de behöver ju ett jordklot att flyga runt.
you fill a little bag with water. Right?
Ja, nu gör vi
There might be some powder in there to give it some taste.
ett stort.
And then you drink out the straw. Or you make it in
Ja,
water.
får vi se.
You can give it
Då är det en
taste.
rymdfärja som åker runt på den.
Cats in Sweden.
Man kan få en inne i den också.
They shop it so that it came in stuff.
Aha. Inte allt som allt har vi en
And
till.
it was like physics.
Och en till. Många rymdfärger som åker runt. Och nu kommer utmaningen. Ska man klara av att få allt där i munnen då?
So I'll just finish up by saying that, yeah, it's amazing being in space. It's so fun. It's wonderful views. But still, our blue marble down here is better. Thank you.
Thank you, Christer. We went to space and discovered the Earth. That's beautiful. So how do we manage this treasure, our planet? What do we need to do? And how do we need to work together? One of the strongest voices calling for action now is Johan Rockström, director of the Potsdam Institute for Climate Impact Research. I asked you to bring a color today. And I've asked all the speakers to bring a color. And Johan said, I'm going to ask you something unusual. And he said, I said no directly. And I said, but you want to listen to my question first. And I said, can you please wear some color? But he's the rebel today. But we need rebels. We need rebels. Welcome up.
I'm really sorry, I knew I would fail you on this one. But I have a little color here on purpose. So, yes, this is the most iconic picture ever taken, the Christmas Day Apollo 8 image, as Krista pointed out. I chosen this version because many photos were taken, showing the transformative speed and scale that we need to secure in order to have a safe landing on a stable, resilient planet that can continue to support the life as we know it on planet Earth. Why? Because science today shows, I would even argue unequivocally, that for the first time in human existence on planet Earth, we are forced to consider the real risk of destabilizing the state of the entire planet. That's what the evidence shows. A lot of it comes from satellites, a lot of it comes from on-the-ground field research, modeling, but actually it's not so new. Kenneth Boulding already in 1966 postulated that we'll live on the spaceship Earth. You know him because he put out this famous statement that anyone who believes in infinite growth on a finite planet is either a madman or an economist. And this is the basis upon which the Swedish Royal Academy of Sciences has actually been leading on the science behind the evidence that we are in the Anthropocene. That we live on spaceship Earth. We're starting to hit the ceiling of hardwired biophysical processes, both living and non-living, that regulates the stability of the Earth system. Krista showed this breathing of the biosphere, keeping the whole, not only photosynthesis and oxygen, but also the stability of the Earth system intact. Well, here is the iconic graph. It was established in this building of the Great Acceleration. What you see here is from 1750 until today on all these x-axis. The red graphs are the hockey sticks of the human enterprise going into scale in the 1950s, 10 years after the Second World War. We're 3 billion people, and bang, we push in the high gear, and off we go on GDP growth, on resource extraction, on unsustainable food systems, and the Earth system is impacted on the green side. All the hockey sticks of impact. You don't have to read the graphs, just remember the following. Any parameter that matters for our human well-being, for the stability in our societies, for economic development, they look the same. Up until the mid-1950s, linear change, then exponential rise. And we are today at the top of these curves, and we're starting to really hit and feel the pain of a planet that is starting to send invoices back to the economy. 2024, we touched 1.54 degrees Celsius. It cost the economy over $200 billion in extreme events, from fires, heat waves, storms reinforced by human influence, all forms of disease outbreaks, and that is the reality we're in. But what makes us really nervous scientifically today is on the screen here. The whole climate crisis that we have been proclaiming very clearly, even the IPCC, the Intergovernmental Panel on Climate Change, is today in agreement. The fundamental consensus across the climate science community, we are in a climate crisis. Those are the lines you see from the 1980s, the gray lines here, up until 2022, on air temperature to the left and sea surface temperature to the right. Then suddenly something happens in 2022. Bang, you see a jump up to that orange curve, and we see a sudden 0.3 degrees Celsius leap in temperature rise. And we cannot explain it. But as you see, the rate is so fast that I've never seen the kind of language that today are used of concern in the scientific community. Just completely mind-boggling. Out of the scope of what should be possible. No models can even reproduce this. This is the statistics we have, the temperature observations from the 5 different sources of temperature measurements around the world, sea surface temperatures from all the Argo buoys, thousands of them across the ocean. And here you have the stats that the last decade seems to show a very significant change in the rate of warming. So something is happening, which I won't go through here. There are many candidates out there. There's a lot of science going on right now. We're kind of in the lab because it's not fully answered yet. But there's one conclusion, which is that we cannot rule out that the planet is showing its first signs of losing resilience, losing buffering capacity. We know that 50% of the carbon dioxide from fossil fuel burning is not in the atmosphere. It's in the ocean and in intact nature on land. This is the largest free service to the global economy, and it's been operating in a linear fashion, very stably for 150 years, but now we're starting to see cracks in that system. We're seeing changes in the stability of the Earth system. So that is what we have to bring with us. The second thing we have to bring with us is that the latest science shows, and that is what KIST really points out, the beauty of the planet, this blue marble and its stability, which is so remarkably stable, but also conducive for the life as we know it. I call this today the corridor of life, because we can actually quantify it. And you've seen the data, I'm sure. This is the last 400,000 years, ice core data showing the temperature variability on Earth, the global mean surface temperature variability. Look at the furthest right-hand chart here, where we are today. We're actually not at 1.2, we're at 1.3 on the moving 10-year average. We're heading towards 3.1. That's the latest assessment by the end of this century. That is actually a temperature we haven't seen on Earth over the past 4 million years. 4 million years. It's kind of winding back the climate clock way outside modern human existence on planet Earth. But look at the last 10,000 years, the Holocene, since we left the last ice age. That is what I call our corridor of life. That's a 14 degrees Celsius planet, plus minus 0.5. 0.5. So the little ice age, when Kung Karl X Gustav brought his army across Lilla och Stora Bält and invaded the Danes from behind, that occurred within this very narrow corridor of life. We left the last ice age 18,000 years ago. We lived in minus 5 degrees Celsius. We've been on planet Earth for 250,000 years. You enter the wider life corridor. Minus 5 is the ice age. The warmest temperature on Earth, according to our latest science, is that we've never exceeded 2 degrees. And you can take that corridor back 1 million years. So the journey that we're following right now is that we're pushing the planet right out of orbit, as it were, right out of the stability that we all depend on. And why this is so significant is that we know we were hunters and gatherers when we lived in the Ice Age. We left the last Ice Age, and we entered this beautiful, very, very narrow corridor. And that's where everything that Krista showed you settled down. The beauty of all the biomes, the water cycle, the carbon cycle, the oxygen, everything we depend on settled down in the Holocene. And that's where we took off with agricultural evolution and had this civilizational development that takes us to the planetary health point where we are today. That to me is a very humbling conclusion, but it's also scientifically very rigorous because it gives us a point of measurement. That is what we use for the planetary boundary science to quantify the safe operating space. The final piece of evidence before coming to what we need to navigate our future is that the Earth system is a self-regulating complex biogeophysical system. It has tipping points. It has biophysical systems that have multiple stable states. Keep them on the right side of the fence, and they will dampen change and be helping us to stay in the Holocene. Push them too far, and they cross thresholds, and they can then self-regulate themselves away from that state, like a savanna becoming a degraded, like a rainforest become a degraded savanna, or a Greenland ice sheet irreversibly melting. Here you have the 16 climate-regulating tipping elements that we have measured. 6 of them are up in the Arctic. That's the ground zero. We live very close to the ground zero on planet Earth. They connect across the North Atlantic with the AMOC, the Atlantic Meridian Overturning Circulation. The Amazon rainforest you see there. Of course, the Antarctic ice sheet. These are biophysical systems, both in the living biosphere, like the coral reef systems, and the abiotic systems. We have now quantified at what temperatures they're likely to cross their thresholds. Admittedly, as you see in the burning embers here, a lot of a wide uncertainty range. But look at the top 5 ones, where the white dots are the median assessments of the most likely temperature thresholds. The Greenland ice sheet, the West Antarctic ice sheet, all the tropical coral reef systems, home to over 200 million people, abrupt thawing of permafrost and collapse of the Labrador Sea and collapse of the Barents Sea ice, likely to cross the thresholds at 1.5. So 1.5 degrees Celsius, which is 3 times outside of the corridor of life, is what I call today a limit. It's not a goal, it's not a target, it's not something you negotiate with. It's something that we have to hold on to very tight. So this is what informs us in setting safe boundaries. We also know that these tipping elements are interconnected, not surprisingly. The Greenland ice sheet and what's happening in the Arctic slows down the AMOC, which impacts on the Amazon monsoon system, which also leads more surface warm saline water to be stuck in the Southern Ocean, which can explain why the West Antarctic ice sheet is melting faster than we had expected. So remember that the Earth system is fantastically resilient and beautiful in a healthy state, but in an unhealthy state, the patient and its organs are potentially cascading ourselves in a worse situation. This actually takes us to why we need planetary boundary science, because it's not only about the carbon and the climate. And I'll just give you one example here. One of the tipping elements is the richest ecosystem on land on planet Earth, the Amazon basin. The Amazon basin holds more than 100 gigatons of carbon. It is a massive producer of freshwater supply. It is the richest biodiversity system we know on land. Climate science shows that the risk of tipping this system is between 3 and 5 degrees Celsius, meaning the risk is not so high. It seems to be quite robust. But the ecologist tells us we're wrong. Because if you lose biodiversity, and if you cut down the trees, the more likely range of tipping is between 1.5 and 2 if you lose more than 25% of canopy cover. That's dramatic, because this is where we are. We are very rapidly approaching a tipping point of the Amazon basin. That's not me saying it, it's Professor Carlos Nobres, the world's absolute authority on Amazon rainforest science. So that's where we are. You put all this evidence together, and my conclusion is clearly, and increasingly in the scientific community, we have to stay within quantitatively science-defined boundaries to have a planet that can support our and future generations. We have identified the 9 planetary boundary systems that regulates the stability and the health of the planet. We've quantified them with a whole number of control variables. 6 of the 9 boundaries, that's what you see here, are outside of the safe operating space, so they kind of verify this worry I've been sharing so far. It's not only climate, it's also biodiversity loss, it's overuse of fresh water, overloading of nitrogen and phosphorus, land system change, loading the earth system with novel entities like PFAS, persistent organic pollutants, and microplastics. We are still in the safe space on aerosol loading, air pollutants, stratospheric ozone depletion, and very close on ocean acidification. But overall, this is the assessment where we are today, and that is, in my view, taking the planet to the doctor. It's a diagnostic of the health of the planet, and of course the big scientific quest now, which I think is topic for this meeting, is what does this mean for human health? Can we connect this much deeper with the human health dynamics? But we must also remember the journey to the future. We are now soon, we touched 1.5 2024. We have the first experience of 1.5 on this planet. But scientifically, that does not mean we've breached 1.5 yet, because 1.5 is defined as a moving 10-year average. The IPCC scenarios, which you see here, are the remaining 100 scenarios in the 6 assessment of the IPCC that can still hold 1.5. Unfortunately, we conclude, and we in this case are the climate scientists at my institute, at the Potsdam Institute, that we can no longer hold 1.5 by simply never breaching it. So what you see here is what I would say is the best offer we can make from science, namely still holding 1.5, but not until the end of this century, after a period of overshoot. And the most likely breaching point is somewhere between 2030 and 2035, very soon, within 5-10 years. And as you see, we're talking 30-40 years of reaching up to 1.7 degrees Celsius of global mean surface temperature. This is under the condition that we phase out fossil fuels by 2050, under the condition that there are no tipping points, and under the condition that we come back into the safe operating space. It's a very optimistic assessment, but it's the best we can offer. Now, what does this tell us? It tells us 2 things. One is, and I'm sorry to say it, but that is a fact, and we need to have that with us, I think. It will get worse before it potentially gets better. Because every 1/10 of a degree, we know without any uncertainty, gives more extreme events, more impacts on human health, more droughts, more floods, more events like the 2022 heat wave that made 60,000 people lose their lives in Europe. And by the way, it happened already in 2003 with 70,000 people. The second conclusion is, why will the planet come back? What is it that makes her come back? Well, it's very simple. It's the health of the planet. We have to come back into the planetary boundaries to have a living biosphere, the pictures that Krista showed, to help us keep the planet from drifting off. So that's why we've now started to do an annual planetary health check. That's why we feel that this symposium is so important here, to connect the Earth system health analysis with the human health analysis. We've used a blood sample test to kind of really carry home the message that we're bringing the planet to the doctor. We're going to do this every year, releasing it at the New York Climate Week. 2025 version is something we're working on already today. 6 of the 9 planetary boundaries are verified to be outside of this safe space. The arrows here show that we're unfortunately still moving in the wrong direction. So this is really worrying. We haven't bent the curves yet, but we still have a chance of doing so. We're also mapping the cost to the global economy. The latest assessment, you may know, are showing big numbers. If we continue on the journey we are today, we have a 2-digit impact on the global GDP loss in income. So we're talking quite significant or very significant impact. I want to put this map up because this is in the annex of this research, and all climate economic analysis bundle up the world in global GDP numbers. But look at the inequities that we're talking about. The red parts of the planet are those that will lose more than 25% of their income, while the blue parts are those that are, which I think is quite questionable, that may be benefiting over the short term of the warming between now and 2050. So this is what we're facing. It's a very inequitable impact as well if we don't turn this around. We have a 200 billion tons of carbon dioxide budget remaining then, if we want to really transform ourselves now back into a safe operating space. That is equivalent to 5 years of emissions. We emit 40 billion tons of carbon dioxide today, so we're talking of an urgency. We're talking speed and scale being the only path to a future. This is the safe landing path, again taken from the IPCC. You see the pace of reduction of fossil fuels in gray. The dark brown, the darkish wedge there is the food system that needs to go from source to sink in red. The orange parts is carbon dioxide removal technologies, and the green and blue is investing in keeping the living biosphere functioning on land in green and ocean in blue. If we don't scale carbon dioxide removal technologies, the orange one, we have to follow this path. So when the European Union and Sweden says zero emissions by 2045, it assumes that we will be successfully scaling carbon dioxide removal technologies. It has already factored that in. So remember that there's no free lunch in any of these carbon accounting schemes, but this is the best that the science can give. Now all this means we need transformation. We can no longer go on with linear change. There's a lot of science going on right now on looking at social positive tipping points. Are there acceleration points that society can bring on board to really go from linear positive change to nonlinear change? And there is, I would argue, a lot of evidence that this is possible, dating all the way back to the theories of diffusion of innovations by Roger Everett, who showed empirically that you have these S-curves of exponential change, and once you have a good solution that penetrates somewhere between 15 and 20% of markets, you can actually tip over the inertia in the entire market. And we have so much exciting data here. This is the growth of renewable energies, particularly comparing the global south with the global north. We often forget that the global south is catching up, is moving very fast on solar and wind and biomass. And you see how Africa and Southeast Asia is actually ramping up and not far from 2-digit percentage points of penetration. The electric mobility transition in the world is moving even faster. And it's so exciting to get the data from Denmark. Just look to the left there, how they're following now an S-curve with 60% penetration of EV mobility in their society. Norway, as we know, has already crossed the tipping point. 90% of cars sold in Norway are full electric. They have crossed the tipping point. There's no moving back. This is hard to abate sectors in the world that we normally talk of impossible to change in time for 2050. This is not a published table. It's my own, let's say, expert personal elicitation. Aviation, steel, cement, built environment, plastics. We often talk of these as being areas that we cannot innovate and scale ourselves away from fossil fuels. Well, when you map and talk to stakeholders, you find that there are solutions across all of these. They've reached different levels of penetration into the market, but I would score them today in the following way, that many of them are green. They're actually ready for scaling out in the competitive markets, often even without subsidies. Admittedly, you have a few red areas where there's still major challenges, but it's quite interesting to see that when talking to the steel industry entrepreneurs, they are really arguing strongly that we have possibilities of shifting away from planet-damaging practices. So I'll leave you with this final graph. This is also an expert elicitation. It's trying to integrate all the planetary boundaries into one assessment of where the planet is. We are in danger. We're outside of the safe green space. But you see we're on this yellow range here, which I call the danger zone. It's the range of uncertainty in science. We're not yet in the red zone, which means that we are in danger, yes, but we can still turn this around, and the resilience of the Earth system remains still intact. So I would like to say that when Billie Eilish brings out her very powerful statement that the party is over, my message to you is, yes, but the game is not over. Thank you very much.
Thank you, Johan. Really food for thought and flesh on the bones here. We will come back. We will have a joint panel with all the speakers with the possibility of comments and questions. So we are talking today about the concept of planetary health. But what does it really entail? Here to frame this concept, I would like to welcome Josep M Antò, Scientific Director of the Barcelona Institute of Global Health and University Pompeu Fabra in Barcelona. Most welcome.
Thank you so much. Well, such a big pleasure to be here today. Special thanks to the organizing institutions, organizing committee, to Peter Stewinkel. And well, I have begun with the last speaker with a question that this is what we have, and now this goes to the doctor. And I think that this is really what it has to see with planetary health. And I want to begin with sharing with you a personal shift in my academic career. And this was in 2015, when I was reading a paper that was describing a paradox. The paradox was the one that you have here. So we have seen the changes in the Earth. We have seen in the last presentation 6 boundaries already transgressed during the last 50 years, basically, or 70. And nevertheless, the global human health has been increasing, improving, with huge inequalities, but in average, improving at an unprecedented rate. And then how you can reconcile these two opposing trends. I must tell you that when I read this, I had been for more than 30 years teaching environmental epidemiology and public health, and my first reaction was to believe that it was a wrong formulation. There was something wrong in the paradox. Then I realized, as the authors say, that unfortunately the answer to the paradox was relatively straightforward. It was that we have been mortgaging the health of the future generations to realize economic and health developments today. And this paradox was the beginning building block of the report in Lancet in 2015. This was the reading that changed my way of understanding as a doctor, as an epidemiologist, human health. And in this report, it was, traditionally a large book. It's 56 pages, more than 400 references. But probably one of the main messages, it was, if we understand the paradox, we need to change the way we think about human health, as doctors, as people, as citizens. And then they proposed a new definition of human health, in contrast to the definition that still today is being used officially by the WHO. And they proposed by the first time, it was not the first paper on planetary health, there had been others before, but this was the formally defined planetary health in this way. So this is the achievement of the highest attainable standard of health, well-being, and equity through a judicious social, economic, political development, because these systems are the ones that, as we have seen in the previous presentation, shape the limits of this marvelous planet, as we had the privilege to share in a way that makes inhabitable for humans. And this definition of planetary health, which is semantics at this point, as we have seen previously, may be important. When I say planetary health, I mean this vision of the health of the planet together with the health of the humans. And the health of the planet obviously includes not only the health of the Earth systems that we have seen, but all living animal and vegetable species. Well, to make this shift more profound, this paper came not only with a concept, it came with an approach. And the approach for planetary health, the author suggested, is an approach that should at least have these 4 components. First one, complexity and uncertainty. Even, 90%, 95% of the research we do today in human health still is based on relatively simple linear models. Now, the scope is another one, and it needs to take into account complexity and uncertainty. The other is the interdisciplinary quantum leap. I'm not going to talk about this today, but we are used to see science evolving. It has been said in one of the presentations at the beginning, by creating new transdisciplinary fields where things become more specialized. It may be interdisciplinary, but became more narrowly specialized. And here we need to make a jump to integrate different understandings from very disparate sciences. This is challenging. And the last two ones, this is urgent. we need to put treatments that are urgently necessary to survive, and this should be equitable. Well, as a doctor that was so unexpectedly challenged by this way of understanding human health, by planetary health, I must say that during the 10 years that has been passed since this original paper in 2015, in a way, probably unconsciously, I was writing something from science to say, well, it may be not so big. Perhaps we have more time. And as a human doctor, as a medical doctor, I was looking to the other side of the science for indications that maybe there was more hope that the science was indicating. Unfortunately, it was not. This is a summary, my personal summary of the last decade. Well, 2018, the panel, the United Nations panel of biodiversity, showing that, well, what we knew about the extinction of life species was right. This was tremendously consequential for humans. 2019, the report of United Nations, the state of health of the environment, with an overarching message, a healthy planet for a healthy human. There will be no healthy humans without a healthy planet. 2019, the high-level advisory board for the SDGs. The future is now. And again, the same message. 2022-23, we had the 6th assessment of the International Panel of Climate Change with different reports. Here you have the summary for the policymakers. Again, the same message that we saw in the presentation of Professor Rockström. Well, this was probably one of my more inspiring meetings during the COVID, and it was again originated here in Stockholm. It was organized by the Nobel Prize Foundation, the Nobel Prize Summit. I attended during confinement at home. And again, the same message, our health, our planet. And finally, you have, as you have seen in the presentation before, the last 3rd assessment of the planetary boundaries, 6 transgressed. So as a medical doctor, I need to accept that this is the diagnosis. And this happens in our life as patients. We have a doctor saying, well, Joseph, I'm afraid I have bad news for you. And you can take or not. You can take different views, but we know by science, this is a reality. This is the disease. The disease will evolve in this way. So this is one need to do with the human health. Well, during the last 10 years, in the same way that this evidence has been accumulating, we have had a steady growing of evidence showing us that we can do important things from the side of the human health. And probably this slide tries to summarize what to me is the second principal fundament of planetary health. The first one is the previous one, is the health of the planet is such that we are in a big challenge. The second one, that again was a surprise for me as a medical doctor, is that this is giving us in health, in public health, in medicine, is giving us unprecedented opportunities to do both. Support the policies that we need to improve the health of the planet, and at the same time, benefit human health. To me, this was a big surprise in terms of public health. It may have not been seen that way, but the reality is that we have opportunities to do policies that are beneficial for the health of the planet and immensely beneficial for the health of the humans. Here you have 2 books of planetary health that it illustrates how the field has been launched in the last 10 years, just a picture of the Lancet Planetary Health. And in the third report of the Lancet in 2015, there was a very nice section, charting the course for the future. And there was a number of fields that were illustrative of opportunities in planetary health. And you can see here you have the urban planetary health, the food production in different fields, integrated land use solution, sound management of chemicals, planetary healthcare, integration of environmental healthcare with health systems. all these fields have been growing a lot during the last 10 years, and I think this is tremendously positive and important. Some fields were not highlighted in 2015. For instance, planetary health care. Today we know that in average in the world, about 5% of the CO2 emissions are due to the healthcare systems. And we have the unique opportunity to reduce these emissions, decarbonizing the health system, and at the same time improving the health of the humans. And this is growing as a new field in planetary health. Summarizing all the evidence has been accumulating during the last 10 years may not be easy. And for this reason, I use this simple table. It's a 2x2 table showing planetary health in 2 dimensions. One is the health of the planet. And remember, the health of the Earth systems and also the health of the plants, of the animals. And the other dimension is human health. And then very simplistically, as we doctors sometimes need to do, it's just bad and good. What is bad and good for humans and what is good and bad for the planet. And then this gives you 4 different categories. And in the left down, you have the co-harms, the things that are bad for the planet and bad for the humans. I must say that probably vast majority of the research that we have today is about the impacts, and it may go to this category. Obviously, this is fundamental, but it's fundamental because it's the input for solutions, and what really matters is solutions. And solutions are in the upper 2 cells. In the left, you have what is good and good. And here we are today using this concept, which is new in public health, of co-benefits. It means co-benefits for the health of the planet and co-benefits for our health as humans. And this is basically what we get frequently from mitigation policies. And in the right, in the upper right side, you have something that it's a bit more difficult, which is the trade-off. Things that are good for us, but are bad for the planet. Here is where typically healthcare fits. It's good for us in proper conditions, but it's bad for the planet. And here we have opportunities for mitigation again, but also opportunities for adaptation. Well, the one in the low left, which is what is bad for us and good for the planet, I found this to be a very ambiguous and difficult, and I left it for you. Well, I just got a terrible news that I have 1 minute, and I will need to summarize the following slides. So, a lot of research about solutions. Go to this paper in the Lancet, the Pathfinder Commission. More than 200 actions in 20 reviews that have been assessed simultaneously in terms of reductions of CO2 and gains in years life lost. Help the planet, help the people. Well, the more positive ones for human health, improve cookstoves. The second one, improve diets. The interventions in sectors that are better for the health of the planet are the multisectorial and energy. By the first time, we have this metric that puts together CO2 in tons per capita and years of life lost for the population. Interventions are very contextual, which is a challenge. And this is for nature-based solutions. The Pathfinder Commission found that there were no reviews on nature-based solutions that can be translated in joint metrics for the planet and the humans. Nevertheless, in the right side, you have 31 randomized control trials, which is the more stringent design for scientific evidence, in 16 them showing nature-based solutions to be effective for mental health, physical activity, cardiometabolic, and inflammation. All of this is about mitigation, but the impacts are already here. And I think probably one of the lessons of the last 10 years is adaptation. It's urgent and we need it now, today. Well, upper you have the paper that we did in our institute with Joan Ballester, 60,000 deaths in 2022 in Europe during the summer. Mortality twice higher for women than for men. And in the low side of the slide, an indicator from the Lancet Countdown in Climate Change and Health that I have the privilege to co-chair with Professor Maria Nilsson, that is here today, unfortunately showing in Europe only 10 countries reporting annually vulnerability and adaptation assessments, and only one country reporting that these assessments resulted in important changes in resource allocation. Well, two final messages. One is the urgency. We have already seen this in the previous slide. With the policies that we used to have in public health for the last 30 years, in the best case, they are examples of integrated policies. This is not enough as the time is passing, and we need transformative policies, the kind that you mentioned, social tipping points. And the other cross-cutting message is equity. This is a diagram from the last Worldwide Inequalities report in carbon emissions, and you see that in the right side, the bottom 50% of the human population have 12% of emissions and have 75% of the impacts. And they have only 2% economic capacity to adapt. So this is a fundamental challenge that we have. With this, I finish with a call for hope that came from this picture from an artist from Galicia, Isaac Cordal. He did an artwork in Indonesia for denouncing the monoculture of palm oil. He worked with these small sculptures. It was done before the COVID, so the face mask here is before the COVID. And then they allow people to visit the exhibition. This young girl was looking to the small sculpture, and then the artist, Isaac Cordal, took the picture. It gives me a sense of hope, and I am sure that this meeting will be also a nice input for our hope and our science to face the challenges of planetary health. Thank you so much.
Thank you very much. Joseph, for giving us a bit more of the background here. We have talked about the planetary health approach on a larger scale, but what does it really mean for people on the ground? How can we bring a new type of support to people in exposed areas? We have Rafael Ruiz with us, de Castañeda, right pronunciation, yeah. Head of One Health Unit at the Institute of Global Health, University of Geneva. Most welcome. I'd like you to remind you 18 minutes, please.
So thank you very much for the opportunity, for the invitation. It's really a pleasure being here today, and congratulations and thank you for bringing us all together. I think the panel and the group of experts and collaborators you brought together at this event, it's very, very impressive. And I really wanted to be here, knowing also the fact that in Geneva today, I'm based in Geneva. I've been based in Geneva for the last 10 years. Today we start the World Health Assembly. So all the ministries of health from all the member states are in Geneva today. And during the whole next 2 weeks, so much going on in Geneva, but I really wanted to be here with you today and then flying back after tomorrow right away, because again, so much going on in Geneva these days. I'd like to give you a very quick overview on and I think my colleagues have already set the scene impressively. And I'd like to also give you a very quick overview on how these concepts, not only planetary health, but also the One Health concept, have evolved over the few last years, and particularly post-pandemic period, if you want. And also trying to highlight how I see personally, and I'm again wearing a little bit of my Geneva hat today. We often like to say Geneva is the capital, or at least the Geneva history is very tied to the history of humanitarian action, humanitarian response, right? So I'd like to also discuss with you and how One Health and planetary health are methods, our tools, our way of thinking to also support and help the people that are really confronted to this emerging, re-emerging, or exacerbating humanitarian crisis that we see all over the world. So just quickly, I mean, you've set the scene very impressively. The scenario is extremely worrying, extremely concerning. But on the other hand, I think following the post-pandemic, we'll also see some very exciting times, in the sense that we see an unprecedented global health momentum moving forward. Parenthesis, also a crisis on global health, as you know, these days. But as you follow this diagram, and this is just a screenshot we took from one of our recent publications, if you go back to up to the top in 2020, so the Quadripartite Alliance was constituted, bringing together the tripartite, which was the World Health Organization, the FAO, the World Health Organization of Animal Health, and now bringing the environmental component, the United Nations Environmental Program, back in 2020. So this was quite an important moment in time. 2021, this is to give you an example, also very much at the core of my area of work. So the World Health Organization launched the roadmap for tackling neglected tropical diseases. Many of these neglected tropical diseases are very, very connected to the environment, very, very connected to human health, animal health, and One Health and Planetary Health makes so much sense, right? And it's very much part of the strategy that the WHO has been working on. By the way, I've worked at WHO for several years, and I've been part of this process and working with the NTD department. 2022, United Nations General Assembly resolution on ecosystem services, and ecosystem services, at least some important ecosystem services being a human right. That's another important point, I think, in time, and many others. 2023, I'll go back to that, United Nations Climate Change Conference in Dubai, COP28, where again, this was a very interesting moment in time for humanitarians. I'll go back to that in a second. And many other events that we are seeing through 2024. And as I said at the beginning, this is happening right now in Geneva, the World Health Assembly with member states, Ministry of Health represented in Geneva. We see the World Health Assembly agenda for the coming days. Planetary health, One Health related topics are very much at the agenda these days. So important discussions around AMR, antimicrobial resistance, important discussions after more than 3 years of negotiations around the pandemic agreement are going to be backed and accepted, hopefully, these days in Geneva. At the same time, we have important discussions and agreements taking place around climate and health, pollution and health, among others. If we move to the science and if we move to the scientific space, we also see these growing trends in the number of publications, and that's probably partly what brings us together today. Many of us are active scientists working in One Health or planetary health related topics, and we see this growing momentum in the scientific interest and an increase in the number of publications, particularly post-pandemic after 2020, 2021. And what we've seen in parallel, and we as scientists, we often like definitions and we like these academic discussions, right? We also seen how the two concepts, planetary health and One Health, have been defined academically, but we've also seen an evolution of the interpretation of these definitions and multiple definitions that somehow are conflicting, overlapping, or simply, being complementary. So the first definition, and my colleagues have already highlighted this one, was the first definition of planetary health was proposed by this impressive Lancet Commission back in 2015. It was a broad definition that refers to planetary health as the health of human civilization and the natural system on which it depends. It was a very broad definition that was then complemented by a second definition proposed in 2021 by the Planetary Health Alliance, that had basically two components. One component which was a field, if you want, a solution-oriented transdisciplinary field, and at the same time a social movement, which I think is very exciting. It's not only scientists working with scientists, but scientists working with society, right? So very transdisciplinary. If we move to One Health, on the other hand, so One Health is in a way a little bit older. If I go back to the initial definitions, and there is still a little bit of discussion on where we set the cursor, of the origin of One Health, but I like this idea of one medicine, right, which is a very pan-species approach, a multi-species approach to medicine and to health, where basically there is no inherent difference between our anatomy, our physiology, our way of living compared to other animals. We are all animals in a way, so this whole idea proposed back in the 60s by Calvin Schwabe, who was himself a veterinarian, and who highlighted this pan-species approach to medicine. Then I like very much the second definition, which is in a way a little bit of a Swiss definition, because it was proposed by our colleagues at the Swiss TPH, not far from Geneva in Basel at the Tropical Medicine Institute. And it's a very actionable, operational definition. One Health and planetary health are often criticized of being too theoretical. I like this definition because it's very practical, and it really builds around the idea of demonstrating quantitatively or qualitatively the added value of collaboration. What if we bring together these groups, this discipline, this sector? How can we show an impact? How can we show a benefit? How can we actually show that we're saving money by doing joint vaccination campaigns in sub-Saharan Africa by sitting together in the same car, public health specialists and veterinarians, for example? Or we are simply sharing the same cold chain, right? We're saving money, okay? And we're dealing with countries that are extremely poor in many of these situations, so saving money, it's always a critical aspect. What if we are also saving time just because we early detect emerging infectious diseases at the source rather than detecting them late in time when we're already an epidemic rolling out through the human population? So that's a way of demonstrating with specific indicators how there is a real interest of collaborating across disciplines and sectors. And there is a lot of evidence around this and growing evidence. And just to make things a little bit more complicated, at the same time, as I told you before, in 2021, the Planetary Health Alliance proposed a new definition, if you want, or a second definition of this idea of planetary health. Almost at the same time, we had a new definition of One Health, 2021, in this case proposed by the OLEP, One Health High-Level Expert Panel, and endorsed by the Quadripartite Alliance. And this definition of One Health is, well, first of all, very long, multiple paragraphs, as you can see there. But what I think is quite interesting is we see One Health that has a very veterinary history, if you want, also moving more explicitly to the environmental space and an explicit recognition of ideas like climate change, sustainability, air quality, etc., etc. And this is where we see a little bit of a, let's say, potential overlap, or at least a confusion of people out there. And I see this often also in my students, right? I always like to, I teach several courses at the Faculty of Medicine, at the Faculty of Sciences, and other organizations in Geneva. And it is quite exciting to see how they are more or less confused, also depending on what's their own background, right? When it comes to understand, okay, what is One Health? What is planetary health? What are the limits, right, between the two? How are they complementary? So I always like to do this very simple exercise by asking them, okay, what are the keywords that come to your mind when you think about planetary health? What are the keywords that come to your mind when you think One Health, okay? So interestingly, in many cases, they got it quite right, but still you'll see there is a little bit of overlap and confusion. So climate change is often very central, right, when it comes to planetary health. And then if we move to One Health, they see animals very much being part of One Health, and you can see animals a little bit of everywhere, right? And this is not hard, it's not rocket science, it's just a simple exercise we do in class. What we did as a similar exercise, but a little bit more advanced, was running this bibliometric analysis, right? So instead of coming up with a new definition, obviously, which was not at all our ambition, we tried to understand, okay, what we as researchers understand and do when we practice One Health or planetary health. So it's, in a way, it's a little bit of an evidence-based interpretation, or almost an evidence-based definition of One Health and planetary health. And what we found in this bibliometric analysis, using the literature, again, post-pandemic, so this is only a short period of time, we see indeed climate change being very prominent when it comes to planetary health research. So in many cases, when we do planetary health research, we are doing climate change research, okay? What is also quite interesting is that all the area that you see, or many of the elements that you see on the red part of the diagram, are somehow directly or indirectly connected also to climate, right? Because we refer to concepts like agro-food system, diet, healthy lifestyles, etc. Very interestingly, from an epidemiological perspective, the diseases that you see here more prominently coming out are mainly NCDs. Okay, non-communicable diseases, cardiovascular diseases, physical activity, social determinants of health, commercial determinants of health. Quite interesting. And if you look carefully, you'll also see mental health. Not very big, but still somewhere here. Okay, that's mental health. You'll see that's not coming out so much in One Health. Okay, so the first striking difference for One Health, it's slightly more defined in a way, right? You have more defined areas. You have a very red, a very blue, a very yellow, and a green area, right? One Health, as I told you before, it's very historically linked to veterinary medicine, and you have a very strong connection of infectious diseases, zoonosis, which is not a surprise. This is what we found in the literature, right? So the big areas of One Health research, in a way, are AMR, which again is not a surprise because this was part of the International Global Health Agenda already back in 2010 when the tripartite again, FAO, OIE, and the World Health Organization came together to work on One Health. This is back 2010. So AMR was already a priority, right? And also a priority for research, as you can see here. And then basically what you see in blue and light green or yellow, that's emerging infectious diseases, zoonotic emerging infectious diseases, and a little bit of NTD, neglected tropical diseases. Not only the diseases, infectious diseases that make the, the front cover of newspapers, but also those that we keep forgetting, the neglected tropical diseases. What if we project this into maps, right? I let you guess for a couple of seconds, right? So what is One Health? What is planetary health? Okay. So what you see on that side, that's One Health. What you see on this side is planetary health. And what it is illustrating is basically the areas of the world where the research is being produced, right? The academic and non-academic institutions that are producing the research that we analyzed, right? And interestingly, the map, yes, there are obvious similarities, but there are also a little bit of differences when you look carefully. What you see for One Health, you can see that that map is slightly more populated than what you see here. Right? It is also an older field, if you want, in a way. And what I think is quite interesting is we see One Health research activity more present in areas of the world where the hotspots for the emerging infectious diseases are more prominent, where the risk of a potential emerging pandemic is more important. You can see One Health research activity taking place all along the Rift Valley fever in West Africa, big parts of India, a little bit of China, etc. These are hotspots for emerging infectious diseases, which is very tight, again, to the One Health agenda or the One Health research. What I think is a little bit concerning, if you check on this side, is that the areas of the world that are dramatically affected by climate crisis, by climate change, are not yet populated by planetary health research. So we see a little bit of a mismatch there, in my opinion. So let me take you to these parts of the world, the areas of the world where climate change is having a dramatic impact on the population. And let me wear again that humanitarian hat. A lot of my research takes place in these type of environments. I'm particularly interested in humanitarian public health, humanitarian One Health, if you want. And this is Kakuma refugee camp. This is one of the biggest refugee camps in the world, one of the biggest refugee camps in sub-Saharan Africa. More than 250 people, and probably underestimated figures, live in this area, mainly Sudanese and South Sudanese people, also Congolese people escaping from the war in South Sudan, and all the Central African conflicts, right? And they gather, in a way, artificially in this huge city in the middle of the desert, right? And I always like to say that somehow the planetary crisis is, in a way, also a humanitarian crisis, and this is what we see here. So, diseases and climate-sensitive diseases are rampant in this type of environment. And we have created very worrying, very concerning conditions in this type of environment. These are some of our collaborators and students collecting samples, water samples, to identify Anopheles, mosquito Anopheles larvae. And also malaria is reducing its incidence in many parts of Kenya. What we see here, this is Kenyan territory, but very close to the South Sudanese border, we see malaria incidence growing up dramatically, specifically in this type of environments, right? Which is extremely concerning. At the same time, these are just a number of students and collaborators and community health workers. We mainly work with community health workers with the International Rescue Committee. These are the number of individuals that have been bitten or have had relatives within their environment that have been bitten by snakes, okay? Snake bite envenoming. Right? So extremely, extremely deadly disease. We've been working on snakebite envenoming for years, and it's a health emergency, major health emergency, and people really die from snake envenoming. So these are the figures, very impressive, right? This is not hardcore epidemiology, but it's telling you so much, right? Telling you so much. And both vector-borne diseases, snakebite envenoming, climate-sensitive diseases, just to give you an example. If you look more broadly beyond this specific camp, what we see, and this is I extracted this, and you could use other sources. These are just a list, according to the IRC, so the International Rescue Committee, some of the most concerning and worrying humanitarian crises that are currently happening in the world. And as you can see, there are many common determinants. And in many cases, climate change is directly or indirectly causing or exacerbating many of these crises. So there is a clear commonality around this. If you compare the map at the top, again, this is the map where we project geographically this humanitarian crisis, and you compare that map with the area, the IPCC map showing you the vulnerability of the populations to climate change, there is a clear line with this red area with what you see up there, a big concentration of crisis in sub-Saharan Africa, in the Sahel, and again, here, all the red area with the climate crisis taking place. So again, we cannot neglect the climate crisis, but we cannot either neglect the humanitarian crisis that goes along. This is quite exciting. This was in United Nations Climate Conference, COP28 in 2023. There was an unprecedented representation of humanitarians in this type of event, which is quite unprecedented and extremely exciting. So humanitarians are really taking action, really getting involved in the planetary health, One Health discussions. What is more worrying is that this is a document, this is the action plan by the Quadripartite Alliance, and we are in active dialogue with colleagues from the World Health Organization in Geneva, the World Health Organization on Animal Health in Paris. There is no explicit recognition on One Health and planetary health methods or actions as part of this document for humanitarian settings. And again, humanitarian settings, they have a very specific identity, and there is a uniqueness in the way you work in this fragile context. So no specific recognition, and this is exactly what we're trying to do now. We organized, first of all, this event back in 2023, where we tried to bring together, thanks to the support of the Swiss National Science Foundation, a big representation of humanitarian practitioners representing multiple organizations, from big ones, Doctors Without Borders, for example, and also smaller ones, to discuss how One Health and planetary health thinking, methods, and approaches can be operationalized in humanitarian settings. One of the products that came out, this is very fresh out of the oven. This was published in February 2025, just some months ago. It's a first policy brief that is basically setting the scene to further work, right? And we came up with a specific set of 4 recommendations and very specific actions to use, to implement One Health and planetary health in humanitarian settings. I won't have time to go through the details, but happy to discuss, and more importantly, happy to engage with you, to involve you in this exciting process. I'll be back in Geneva on Wednesday morning to present this document and to extend the conversation. And one of the things I would like to do, and this is where I would like to engage with this broader audience, is trying to understand who does what in the humanitarian settings when it comes to One Health and planetary health. So we really get a global sense of what is possible and to promote collaboration. Thank you so much.
Thank you very much, Rafael, from the systems level down to the very practical humanitarian level. And we will continue on the theme of communities. How do we engage with them? And how could we create early warning systems? I would like to call up Jan Semenza, Head of Health Determinants Section at the European Centre for Disease Prevention and Control, Umeå University. The floor is yours.
Thank you so much. Thanks to organizers for inviting me to be here. To be honest, I feel a bit overwhelmed with all the bad news you've heard here, so I would like to turn it around. I've been asked to try to turn it around and show a positive perspective. What can we do about this? Because I feel kind of suffocating about all the bad news. And let me tell you a story how I got involved in all this. I worked at the Centers for Disease Control in Atlanta. I was an EIS officer, Epidemic Intelligence Service, which is a service that has been killed by the Trump administration, just an aside. And at 9 o'clock at night, my supervisor called me and told me, Jan, do you know what? 700 people are dying in Chicago, and you need to go and figure out what's going on. There's a heat wave, and all these people are dying. Heat wave? What is that? I had isolated a heat shock receptor as my PhD, and I knew everything about heat on a molecular level, but heat waves on a macro scale, this was in 1995. Heat wave was not a common issue that people talked about. So we went into Chicago and we found a polarizing situation between the mayor of Chicago, which is Richard Daley, and the medical examiner, Donahue. And the politician said, well, the medical examiner is just overinflating these numbers. Everybody's dying from the heat. Just because it's heat doesn't mean that they're dying because of the heat, right? He just classifies it as heat. So there's a big controversy. So we asked to set up an investigation, a case control study to find out what's going on. So we looked at the situation and we saw that the heat index, which is a combination of temperature and humidity, skyrocketed really quickly. Maybe I should point at this one. Skyrocketed really quickly. So it went up very, very quickly. And within 2 or 3 days, people started dying. So we set up a case control study to figure out why do people die during heat waves. And obviously, this is a very complex, multifactorial issue. And I don't want to go into details, but I'm trying to drill on some particular issue here that will lead through my conversation today. We did find that people that were embedded in social networks, that had social contacts, they were protected from heat-related mortality. You can see that the odds ratio is below 1, which is a measure of risk that reduces the risk. If you have a friend in Chicago, you're much less likely to die. Even if you have a pet, you're less likely to die. If you live alone, your risk goes up. And so this is one of the take-home messages among the many other take-home messages that we found. But this slide illustrates most dramatically what it means to be socially isolated in America today. I don't know if you can tell what this is. These are caskets of people that are brought to mass burial because nobody knew who they were. I remember we were trying to track anyone down who knew that person who had died in that single room occupancy where they would drink on their own. They had no relatives, no friends, and they're brought to mass burial. This is what it means to be exposed to heat in America without having those social contacts. Based on all the information that we gleaned from our investigation, we set up these heat health action plans. How can we intervene? Nobody has to die from heat-related mortality today. And we basically set up a system where we monitor forecasts, climate weather forecasts, and then we come up with warnings. We reach out to those populations and we try to bring them to cooling shelters. We make sure that they're hydrated and so on. And as a result of this intervention, these early warning systems, heat-related mortality in the United States came down. So this is highly effective. Then 2003, what happened in 2003? We just mentioned it before, there was a big heat wave here in Europe as well, and 70,000 people died during that heat wave in Europe based on excess mortality for the entire continent of Europe. And this was a totally statistical outlier and had this catastrophic impacts on public health. So Europe decided to learn from the US and build these heat wave early warning systems in Europe as well, and heat-related mortality came down. And Josep mentioned earlier that in 2022, there were 60,000 people that died. This is work that was done at the institute that Josep is head of. And you can see that a lot of people in Portugal, Spain, Italy, and Greece died as a result of that extreme heat wave. It was the hottest period ever experienced at the time in 2022 with 61,000 people. So I pay attention to the news quite a bit, I think. And you know, if an airplane crashes in Washington, D.C. with 60 people, we talk about it. These are 300 airplanes with 200 people each. Nobody talks about it. I mean, what's wrong with us? And so then let's check out the next year, 2023. This is 41,000 people that died in Europe as a result of this extreme heat. Again, the hottest time now, 1 year later, again, that caused this record, and 41,000 people died as a result due to this analysis by Ballister and colleagues. And so basically, the situation is tragic because our interventions don't seem to have traction, right? So this is how we would like these early warning systems to work, right? So this is a typical epidemiologic curve, and we would like to measure the climatic conditions to come up with forecasts so we can send out these warnings, not just that it's hot. We need to tell them what to do about the heat. We need to reach out to vulnerable populations and bring them to cooling centers to protect them from the health in order to bring down that epidemiologic curve. Except that what? It's not working, right? We have 60,000 people that died during heat wave, and we're doing this, something is not working. So this is how I would like to turn around, right? So let's change gear, right? How do you put up with this, right? So at the time I lived in Portland, Oregon, and so here in the US they have created this urban grid, which is extremely efficient for transport. You move from A to B, but there is no place where you can actually meet people and make friends. And so this is the kind of social isolation that people experience in the US because there is no gathering place for individuals. And obviously that's compounded by the heat, the urban heat island effect, where the concrete absorbs the heat during the day, radiates at night. Guess what? You don't get a break. You can never cool down. So this is dramatic. The combination of social isolation and this urban heat island effect, this heat stress, is dramatic. Can we combine these two problems? Can we try to set up an intervention, an urban intervention that attenuates the urban heat island effect, and at the same time, we set up a social intervention to increase the social networks, social capital, as I call it, in social networks. And so this is exactly what we did. We went out and we went out into these neighborhoods with a lot of urban blight. We reached out to all these people. How would you like to turn this around? What can we do? We set up these community meetings. I'm half Italian. I believe in food as an organizing tool for communities. We had brunches for like 9 months until we gave gestation to what kind of what kind of plans for the urban environment can be implemented to improve the built urban environment, to attenuate the urban heat island effect. We asked the city to get the permits, and that's another struggle that I could tell you about. And then we brought these people to the table to build those interventions that they suggested. And the good thing is that by bringing people together like that, you can increase bonding social capital, which is basically the connections between your friends and neighbors and people that are the same and very similar to you. And then there's bridging social capital, where you link them to people that are different than you, right? People with power that can sign a permit to build a construction. So you build bridging and bonding social capital at the same time. And so there are a number of interventions. We build urban and vegetation, urban gardens, green roofs, cool pavements, and so on. And all with the intention to attenuate the urban heat island effect, to increase shading and all that, with the social component to build social capital. And these are some images where people come together, build stuff together, green roofs to attenuate the urban heat. Again, a green roof here. This one here is a bioswale, which is an area where the water, the runoff from the city, sinks into the ground and stuff, as opposed to going into the sewer, where we create the runoffs and the combined sewer overflows. And so this again was built by the community for the community. Here, this is a solar-powered water fountains, and all these mosaics were brought by homeless people and installed by homeless people and neighbors at the same time. And if you've been in the US, there are lots of homeless people, and in this case, they were all integrated and working together with the residents that lived in these neighborhoods. In this case, they decided to paint a sunflower in the middle of the intersection as a point to bring people together. Instead of having the grid for transportation, you have a meeting point where people can get together, and you can see all these people, they came together and celebrated this dome structure for a hanging garden where they worked together. I'm an epidemiologist, that's like the kind of disease that we have. We need to document these kind of things. So we did a survey before and after the intervention. And you can see that we did in fact document an improvement in the sense of community. We saw an improvement in social interactions, and then social capital, and even mental health. Mental health improved. So we were able to show an improvement in these indicators that we were after, and we could document that epidemiologically. Let me give you another example from the global south. This one is an example from Nepal, when an extreme flood event happened in August 2014. And I would like to focus on two different rivers. This is the Karnali River here on your left, and the Bai River here on your right. And it turns out those two communities that lived along those two rivers had completely, totally different approaches when it came to these early warning systems. In the case here of the Karnali River, the entire community were engaged in problem solving, in how to protect themselves from extreme floods. In the other case, they were not. And let me show you what happened. In the Karnali River basin here, we had this community-based, well-functioning and well-accepted formal structure of preparedness and disaster management. So the community was involved in how to build disaster management here. We had this community disaster management committee that promoted flood awareness and response. These early warning systems were composed of community members and supported by government government and non-government organizations. And in fact, the impact from that massive flood, they had never experienced anything like it, was much more attenuated compared to the other community here on your right, where there was in fact very poor buy-in to those preparedness measures. They didn't really know how to measure the gouge on the river. When they finally alerted, there was a delay in the message, and the whole communication chain wasn't clear who should do what. And then, in fact, they came out with a warning instead of danger. So when you get a warning, it's like, it's going to be fine, right? There won't be an impact. In fact, it was not fine. They miscommunicated, and people were not able to move themselves out of harm's way. They weren't able to move their movable assets out of harm's way, and 31 people died, and 4,000 people were displaced as a result. So this is almost like a controlled, natural experiment where you can see that in one case you engage communities, in another case you do not, and it has detrimental impacts for these people. And this is the way that I frame it. Then traditionally in public health, we have this very linear top-down approach to public health where the government interacts with public health officials to dictate and communicate with communities and individuals what to do. And guess what? That works extremely well for polio eradication, smallpox eradication. If you look at single issues that need to be addressed, this works extremely well. If we're dealing with the global health crisis that these guys have laid out, this doesn't work because everything is multifactorial and much more complex. You have to look at the contextual issues. You can't look at one issue. You have to take anything into account. I worked on polio eradication, and we are trying to eliminate polio, and we forget about respiratory disease, diarrheal disease transmission, because you don't address poverty, which is the underlying issue of this case, right? So we cannot build on one single issue. And this is what I call lateral public health, thinking outside the box. And this is what you asked me to do, right? So how can we turn this around? And this is what this is how I look at it. A public health system that's now completely, totally connected with all the different sectors, intersectorial collaboration. I call it a dendritic connection with all the different sectors. But not only that, also with commerce, faith-based organizations, family, individual schools, and obviously the most important thing, communities, right? The community has to be in the center of that. We need to bring communities into public health. We need to rethink our paradigm of public health. The way that I define lateral public health, that we need to advance the social networks to improve social capital among people. We need to increase bridging social capital, where people with less power are connected with people with more power, because otherwise we can't do it. They have to be part of the decision-making process to design those early warning systems and interventions. And if we don't, that's just not going to work. So increase the participation for this early warning system. We need to address all these three aspects of risk: the hazard and exposure and vulnerability. Risk is defined by hazard, exposure, and vulnerability. And if you don't address all three of them, it's just not going to work. So you need to engage communities in reduce the heat island effect, blood barriers to protect them from floods. Those are the climate hazards that we're concerned about. We don't want people to get exposed in hot hospital settings where they can succumb to the heat. But we need to break that social isolation and the vulnerability to those heats to get people out of those settings. So we need to, sorry, let me go back here. We need to address all those three different aspects of risk, and they'll build interagency connections and break these agencies out of their predefined jurisdictions and break those confined silos and basically bring them together as out of this traditional way of working in public health. So in summary, the observed climate change impacts are staggering, and nobody except these guys sitting up here in the front row talk about it. In the media, nobody talks about it. I have never heard of those type of messages. We need to work on adaptation. Obviously, we need to work on mitigation, and I don't deny that. But climate change is here, and it's here to stay, so adaptation is essential. And part of that is building social capital and to build that systemic resilience in our society. And lateral public health is a system where you try to think about dendritic stakeholder engagement, bringing them all to the table and connect them with each other. And actually the Swedes are very good at that, to come up with these good adaptation strategies. We're bringing all the different people from different sectors to the table. And so the most important thing is the next slide here. So do you remember when I talked about that sunflower? The point is not that you can see that sunflower from outer space, right? This is not what we were trying to say. This is a beautiful addition to the built urban environment. It creates a gathering place for people, but this is what it's all about. In this case, the community came together to lift this iron dome up onto the pillars to create this hanging garden. And this is like an Amish barn rising ceremony. I don't know if you're familiar with that, where the Amish all come together and they rise the barn together. And this is what it's all about. This is what we need to get to. This is where we're gonna go, bringing that dome together. People, when we organize this, people say, can we just get a crane and do this with a crane? No, you don't get the point. The point is doing this together, right? Social capital, that's where we're at.